Now that I've given you an overview of reactive programming, I'm going to take a quick detour and talk a bit about the structure and the functionality of the Java Completable Futures framework. And then we're going to come back in the next lesson and talk about how Java Completable Futures maps onto those principles we already defined in terms of reactive programming. So right now I'm going to talk about the way in which the framework for Completable Futures is designed and some of the capabilities it provides at a fairly high level. Of course, we're going to get into a lot more of the details of these capabilities very shortly as we get further into the slides. So Java's Completable Futures framework provides an asynchronous and reactive parallel programming model. And you'll see here in a second what that means. It's really quite a bit different than what you may be accustomed to if you're familiar with what we get with Java parallel streams. It's a very different way of programming in a lot of ways. So just for fun, and we'll cover this example in more detail later as well, but just as a baseline, consider a web crawler implementation that's designed in a purely synchronous way. What that means is that there's perhaps one thread of control, and all the calls that one thread of control makes will block until they finish. So the first step in this process, in this synchronous example, might be to download the start page, the original HTML page that we're going to use to begin our crawl. And then we're going to go in step 2 and we're going to count all the images on that page. Then in step 3, we're going to count all the images that are reachable via hyperlinks on that page. And then the final step here is we're going to combine all the results together to create a total count for the number of images that are on the page. So those are the 4 steps in an entirely sequential and synchronous implementation. And what's important to recognize here is that the time that's needed to perform all of these steps is the sum of the time required to do each step sequentially. So we're not getting any benefit of multiple cores, we're not getting any benefit of concurrency and parallel processing and so on and so forth. In contrast, Java's Completable Futures framework supports dependent actions that are triggered upon the completion of asynchronous operations. So operations will run asynchronously in the background in threads that are part of some thread pool. And as those threads complete, then that's going to trigger other dependent actions that will keep running, which will also typically run asynchronously. And so the whole system will basically be a sort of a directed acyclic graph of asynchronously operating operations, which as they complete will trigger other things to run next. So here's a way to model that web crawler example that we looked at a moment ago using sequential and synchronous processing in an asynchronous way, in a parallel concurrent way. So what we're going to do here is we're going to have task 1, which is going to be to get the start page asynchronously. And then once the start page is obtained, we're going to go ahead and have 2 tasks run in parallel. Task 2 and task 3 will essentially be kind of forked off, and they will, one task, task 2, will count the number of images on the page asynchronously, and task number 3 will count the number of images reachable through the hyperlinks on the page asynchronously. So 2 asynchronous tasks that run in parallel. And then finally, when both of those tasks are done, then we're going to go ahead and join back together again in our flow control diagram and combine the results to give a total of all the images that were reachable from that original starting point. So you can see here that we're going to get a lot more opportunities for parallel processing here. And thus, the operations we see can be forked, chained, and joined. So you can start something off in task 1, then we fork a couple of tasks off that run in parallel. We can chain together a bunch of operations done there in parallel. And then when we're done, we can join everything back together again and combine the results and sum them all up. The cool part about this is that the asynchronous reactive programming model supported by Completable Futures allows the code to look like it's synchronous in the sense that something happens after something else. And that's through the use of things called completion stages or completion stage methods. But actually what's happening under the hood is that those computations are running in parallel or asynchronously, and then their results are going to be obtained and used to trigger the next dependent action in the chain. This will all become a lot more clear when we start talking about completion stage methods in more detail. The asynchronous operations that we're running here can can operate in a thread pool, and that thread pool can either be the default, which is the common fork join pool, or you can have your own custom fork join pools, and you can also have other kinds of thread pools as well, either ones that come out of the box, like the cache thread pool or the fixed size thread pool, or you can define your own thread pools if you want to get even more fine-grained control over where the computations are going to run. This is a very powerful capability that comes with the framework. And note that that's in distinction to the parallel streams framework, where everything always runs in the common fork join pool. As a consequence, the time that's needed to perform all the tasks is no longer just a sequential and serialized time of each task basically appended one after another in some sequential order, but instead it's a function of how well these tasks can be parallelized on multiple cores. So you can actually get a big speed up in performance by having lots of things running concurrently, and you don't have to wait for one thing to finish before you start the next operation, as long as they don't have any dependencies on each other. Now, it turns out that the entire Java Completable Futures framework resides in a single class that has over 60 methods in it. So this particular class is a bit daunting, and quite frankly, one of the reasons why sometimes people are a little bit reluctant to use Completable Futures at first is they get intimidated by the facade or the API in the Completable Futures class, in the Completable Futures class. Now, it turns out, as we will do in this lesson and all the subsequent lessons on Completable Futures, we're going to kind of break things down into smaller chunks. So you'll see that there's some number of methods in the 60+ set of methods in the class API that are what are called completion stage methods, about maybe 40 of them or so. But then there's also a bunch of other methods that are factory methods, basic methods, exception methods, and so-called arbitrary-arity methods. And I think it'll be easier to understand the form factor of this class by decomposing things up into these different categories. So I think that'll help make things a lot more clear. Now, one of the other cool things about Completable Futures is you can combine Completable Futures with sequential streams, which we've already covered, and you can, of course, use all the various functional programming foundation features in Java, like method references and Lambda expressions. And you can combine all these things very nicely to give you a more powerful reactive programming model. And we'll take some looks at examples of things that do that. And in fact, your next programming assignment number 3, will involve combining Completable Futures to do the asynchronous processing with Java sequential streams to give better structure to your overall program. Another nice thing about Completable Futures, which is echoing the nice things about parallel streams, is that you often require little or no explicit synchronization. You don't have to do synchronizers, usually. And you also don't have to explicitly spawn threads and manage thread life cycles and join threads and so on in order to develop parallel programs. So it kind of shields you from all of these inherent and accidental complexities of parallel programming within a much cleaner and more scalable functional programming API. In particular, you can often use the Java class library mechanisms, things like concurrent collections, or in fact, in many cases, just the low-level calls, things for doing I/O, for example, are already properly synchronized inside the library. So you don't have to put any explicit locks in your code in order to protect shared mutable state, which is really nice. So that's the end of the quick overview of Java Completable Futures. Obviously, at this point, you would not be in a position to do any programming with Java Completable Futures because I haven't explained the API in any detail. But never fear, we are going to cover that in quite a bit of detail in upcoming lessons.